Thanks for the lovely introduction, Kate. So I've really wanted to come to try Swift for a while now, especially because I lived in New York for 3 years, but somehow the schedules never worked out. So I'm really glad I could be here today and looking forward to all of the great talks, both on and off stage. All right, so before we dive into the talk, let's do a little show of hands. Who here likes SwiftUI? Okay. All right, some of you, good. Let's hope to keep it that way. So who here has used SwiftUI? All right, okay, so I get to teach some of you something new, and maybe some of the rest of you can help me figure out some problems. Cool, so this was me back in June after Apple unveiled SwiftUI WWDC. And this was me after I got the opportunity to collaborate with the RayWenderlich team on Emetron, the new mobile app coming to you all very soon, where you'll be able to stream and download all of their screencasts and video courses. And we're doing it all in SwiftUI. So we've been developing this app for a few months now, and the journey has been a little rocky. From code-breaking betas that make your Xcode cry, to lying compilers that will deceive you to no end about where the actual problem is, to spending hours upon hours in a deep, dark hole only to find out it's an Apple bug. Yeah, but on the other hand, it's also been a fantastic learning experience that taught me a lot about patience, for example, and how much time we waste creating collection views when we can literally just do this. So most importantly, it gave me the ability to be part of the development of this whole new standard, where you get to both understand the how and the why our framework evolves the way it does, and be able to influence it just a little bit. So I honestly struggled a lot about what to talk about until I decided to just talk about the thing that I struggled with the most, which is basically the paradigm shift from UIKit to SwiftUI. But specifically, I found it difficult to reconcile my desire to create reusable UI components while managing my data in a SwiftUI way, particularly in table views, or lists now. So today, I'll show you how we implemented content filtering on Emetron and the thought process that went behind it. But before I continue, I just want to note that as SwiftUI is an evolving framework, none of this is set in stone, so I'm happy to have a discussion about what you all think about these topics as well. All right, so this is the main part of Emetron, the listing of the content on the left and a way to filter it on the right. Tapping on this button brings up the filter screen, where the user can select different types of content filters. And tapping on the close/apply button applies the filters to the main library. We expose the applied filters on the main view and let users quickly get rid of them by tapping them away. Seems pretty simple, but it wasn't. Okay, so let's make sure we are all actually on the same page about what SwiftUI is. SwiftUI is a declarative framework for building user interfaces across all Apple platforms. Conceptually, what that means is that the view is a function of state, not a sequence of events, which admittedly is still a little abstract of an explanation, so let me give you a simple example. Let's say you have this checkbox. In UIKit, you'd create a new view. You would style it for when it's on and when it's off, and then respond. First, the user taps on the control. You switch the view and the isOn property, then call a delegate method to let the parent know about the change and deal with the new data as it sees fit. This results in a multi-directional data flow that is prone to bugs because you have to keep at least 2 versions of the same data in sync. No, not good. In SwiftUI, you still create and configure, but basically do the exact opposite with your data flow. When the user taps the view, you change the state, which is owned by the parent, and the view reacts to that change in state, not the other way around. thus achieving a unidirectional data flow where there is a single source of truth for the data. So state, or data, is the queen in SwiftUI. Without data, there is no state, and without state, there's really no point in SwiftUI. And passing data, especially passing data back and forth in a table view, was definitely one of the most confusing parts to grasp for me in this paradigm. In SwiftUI, opposite from UIKit, there's a very clear separation of mutable and immutable state, because all the views are structs, which means that the views are value types rather than reference types, and therefore none of the normal properties a view has are mutable. But obviously, we have to mutate the state at some point, which we can do with SwiftUI's new property wrappers, like atState, observed, and environment object. atState helps the view manage its own state and triggers UI updates on itself. For example, if this checkbox was purely concerned with itself, we could create two functions that return two different views. One for when it's checked, and one for when it's not. We tie it all with a button to make it interactive, and keep track of the changes with an isOn property marked by the atState property wrapper that allows the view to read and update its value by toggling it when the user taps the checkbox. So in this example, the checkbox both owns and mutates its data in a unidirectional flow. So now we have this lovely reusable checkbox component that doesn't really do much except for look pretty because it's not communicating its change further up the stream. In order for it to be actually functional, the checkbox should not be the owner of its state. It should only be mutating a state reference that gets passed down to it. So on a tap, it needs to traverse up the state chain of command to the state owner, which should be the only one mutating the state. And then that owner disseminates the new state amongst all of its children. And to communicate in this way, we can use atState with atBinding, which allows two views to have back and forth communication by sharing a reference to the same object. Let's say we have a lamp in a room. This lamp can be turned on or off from this central dial in the room or from the lamp itself. We can model this with views and instantiate the lamp with the isLampOn property to tell it whether it's on or off. And as we've just learned, if we mark isLampOn with atState, we can mutate that state. And every time it changes, the room will re-render. So the room can now tell the lamp to turn on or off. But currently, there's no way for the lamp to do the reverse. We can achieve that by marking the isOn property on the lamp with atBinding to bind that property to the reference it's created with. To bind the value, we'd add a $sign before when we instantiate the lamp. Now lamp has a reference to the room's isLampOn, so when the lamp changes isOn, it is also changing the room's isLampOn. Okay. So this technique doesn't just apply to state. It works with any of the available dynamic view properties. So it could be atState, atEnvironment object, or atObserved object. Okay, so let's take another look at our filters now. We'll start from the ground up and focus on creating this bit first. In particular, let's figure out how to use our checkbox to make this new title checkbox component to then build out a list of these representing all the platform filters. So title checkbox has a name and an isOn state, which makes it the source of truth for this data. We share the state with checkbox by marking its isOn property with atBinding. So now whenever either of the views mutates the property, they both get re-rendered. Cool. SwiftUI makes it really easy for a parent and child to communicate between each other. So now we have our component, sort of. This is kind of the point where most tutorials out there tend to stop. You've created a control. It's really simple. It's easy to understand. It seems reusable. All it needs is a title and an on-off state, and you can plug it in whenever. But at this point, the control is still kind of meaningless because it's not communicating its changes outside of itself, which is the whole point of a control. And you might think to yourself at this point, well, what's the big deal? You can simply just hoist the state ownership up another level to the parent. But let's say that our views are really lean and composed of lots of smaller views. You can imagine that this could quickly get a little out of hand in a larger scale application, especially in a real-world application with multiple view dependencies where each parent view likely has many more than one child view to pass its data to. In fact, in their WWDC data flow video, Apple does caution against using @state too liberally. So @state should be used very sparingly for data that is exclusively owned and managed by the view itself, like the highlight state of a button, or whether a modal is presented or not on top of another view. And unfortunately, this @state, @binding approach especially falls apart when you're trying to create a table view that mutates state. Let me show you. All right, so taking another look at what we're trying to build and getting rid of all the fluff, we can break down these views into components and state. So to render this view, we'll have a filter state controlled by both the library view and the filters view. The filter state will have a property called applied, which are the filters that are actually applied to the content that the library is showing. Then we'll have editable filters, which is the data the filters view is showing, so that when the user interacts with the filters, we don't actually change what gets applied until the user confirms their choice by tapping on the close/apply button. So lastly, we have an rFilters same property, which compares the editable filters with all possible filters to see if there's a difference in which ones are turned on or off. Basically, all of these properties and methods are a little much for @state, especially because we need to share it across multiple views. Luckily, we have two other options: environment and observed object. So if a state lets a view communicate with itself and binding lets multiple views communicate with each other, then we can think of @observed and @environment object as two dynamic view properties that allow a view to communicate with its model by conforming to the observable object protocol. It's part of Combine and automatically adds a publisher to any object that emits a signal before an object changes. So let's go through a concrete example by creating a view model for filter state. We'll start off by adding all the necessary properties I mentioned, the all filters, the applied filters, the editable, wherever they're the same, and a couple of methods. Next, we'll conform to the observable object protocol and decide which properties should be observable by marking them with @published. This makes it so that anytime the properties are about to change, a signal will trigger. If we want to manually control when the change signal gets sent, we can instead create a pass-through subject property and emit the signal whenever we want to call by calling send. That's pretty cool. OK, so this is where we left off with our component. The current implementation of the title checkbox obviously won't do because it owns its own state and it's not communicating it anywhere else. So let's see how we can integrate it into the larger whole. There are only a few moving parts here. There's the heading, the filters list, and a close/apply button. These make up the filters view, which gets its data from filter state that is owned by the library view. Observed and environment object are very similar. There's a slight difference in syntax in how we pass these along, but the only real difference in them is that when we pass an environment object to a view, it gets inserted into the environment and can be accessed by all the children of the view without directly injecting them when we instantiate them. So basically kind of like a singleton, which I know, it's like a little bit of a scary thought, definitely worth considering as you develop your code. Anyhow, we'll go with the environment object for now. And as such, our filters view implementation ends up looking something like this. Now on to the title checkbox. First, we change the state to @binding, and we move the state ownership to the parent, the filters view. Now, instead of initializing a title checkbox with just a name, we can initialize it with an isOn bound state reference. Good. But since we're building a list of these, we can't just have one. To make a list with SwiftUI, we use this for each structure to loop through all the filters and create our individual views. But when we access this filter, it doesn't actually retain any of the bindable aspects of the environment object. Even though if we access the filters property through the $sign elsewhere, we can see that its immediate properties are annotated with binding, as are the elements of the array. But that still doesn't work for our for each struct, though. Since we can index into bindable array members, though, we can just change the for each to its enumerated version. That makes the compiler happy, and we can run our code. But in beta 4, this actually caused a crash. Accessing state outside view body. It's been OK since then, although it definitely makes me wary of using this. Because while I don't think that it's accessing state outside of the view body, who knows how actually Apple defines that. And they have explicitly said in their WWDC videos to not access state outside of the view body. So whatever you do, don't have any properties annotated with @state in your models or anywhere else outside of view. Okay. Another reason why it might not be a good idea to use this enumerated version to get things working is because if the array data changes, so elements get added or deleted, you'll get a crash. For each should only be used for constant data. This can definitely be a problem in our scenario because we get the possible filters from the back end. So it makes one wonder if the ID in for each is kind of like a similar function than a cell identifier in UIKit. Coincidentally, it's also not possible to use that state inside a function yet. All right. Anyway, moving on. We can find another way. So one way to make this work is to make the title checkbox and checkbox a little less generic and reusable, sad, and have them accept a specific model like filter rather than a generic isOn and a name, which, by the way, seems to be what Apple is doing in their tutorials. So from where we create our list, we'd pass down the filter to title checkbox as an @state filter object, and then bind it to the checkbox, which is quite annoying because now that I've made this control very specific, I can't reuse it anywhere else. Because instead of being instantiated with a simple bool and a name, we're now tied to passing a specific model. All right, but at least, ideally, then, we should be able to mutate the filter itself on the checkbox level and let the change travel upstream level by level, and then respond. But alas, that is not how it works, because the filter is only bound as far as the title checkbox, since there's no way to bind to any individual array element. So we actually have to grab and mutate the overall filter state right here at the checkbox level. Let's remember the view hierarchy at this point. We have a filters view that gets instantiated with environment object of type filter state. Then we have a list of title checkboxes. And finally, in each title checkbox, there is a checkbox, which means that the checkbox has access to the filter state through the environment object property, which we can expose by simply adding it at the top as a new property marked with @environment object. Then we need to change what happens when the checkbox gets tapped. Now, this is where things get really fun. We don't actually know which filter is being tapped on to know which one to change. So in order to figure that out, we first have to find the index of your filter in the editable array. And then use that index to toggle the isOn property of the array element at that index in the editable array. What the heck? This seems wrong on so many levels. The checkbox, the humble checkbox, knows way too much about the state. But it is what Apple does in their Landmarks app. And I was starting to get really conflicted at this point. It actually gets even worse in our case, because we have to maintain two separate arrays of filters, one for editing and one as a source of truth for what is actually applied and what is not. So once this change trickles upwards, it changes the isOn property of this filter, which then causes a crash here when the view gets re-rendered because we're force unwrapping a filter that doesn't exist anymore. So now that we're in this mess, we just have to commit to it and do something even worse. And first, filter the editable filters array by the name of the past filter, so we ignore that isOn property completely. And only then do we get the right index and no crash. So now we have this tiny little humble checkbox, which is at all not reusable. And it displays all sorts of code smells. By manually extracting a filter from a singleton type data, it can just access on demand and then mutate it. And mind you, it would feel just as weird with using observed object instead of environment object, except that we'd be explicitly passing it down 3 levels deep. So at this point, I've kind of had enough. And all I wanted was to create this reusable checkmark component that I could use on its own, like here, or in a list. I feel like that should not be too much to ask. But all of the ways of communicating data back and forth with binding seem to have failed me in this quest. And Apple itself was not being very helpful. So I decided to just do it my way. So first, I just kind of removed the bindings altogether. And instead of relying on the bindings, I decided to pass in a callback on both the title checkbox and the checkbox for when a change happens. And finally, update instantiation for the checkbox and the on-tap action for the checkbox button. Finally, this now results in our filters list being implemented like this, where we let the filters view manage the state. We still have to do some index wrangling that's not ideal, but at least we, A, avoid trying to access non-existing elements, B, don't feel like we're abusing the environment object like a singleton, and C, we have our usable checkbox component. Yay. Thank you. So that was quite a lot of stuff to get to this point where we can see what filters are applied and change them from both the main screen and the filter screen while making sure that they're both accurate at all times. Wow. All right, so let's do a little recap quickly on what we've learned. First, we learned what SwiftUI is, that it's different from UIKit by enforcing a unidirectional instead of multidirectional data flow that simplifies development and reduces bugs. Next, we learned about some of the different ways of passing data between views, and how that data passing and data binding can be challenging and confusing when building lists. Finally, we took a look at some examples of how you might approach experimenting with your code when there are little to no prescribed patterns on how to achieve what you want. And even though Apple might suggest a certain way of doing things, it's not necessarily the best for your use case. So to wrap up, here are some of my suggestions regarding rendering lists and passing data back and forth. If my data comes from an array that will remain constant, and I want to use a reusable view for the rows, your best bet might be to use the enumerated version of the for each. If the view is model specific, I'd use the identifiable for each with binding. And if the view is reusable and the data is dynamic, definitely use the identifiable for each and probably callbacks at this point in SwiftUI. The holy grail of how this should work, in my opinion, would be doing something like this, where you can bind a Boolean from a model collection element, where the Boolean will then affect the model, and that change will then trigger the collection to republish and invalidate the views that use it. OK, so what's next? Well, here are a couple of links for you to check out. I'll publish the slides after the talk, so no need to copy them. But first, we have all the code examples and explorations of this talk are available at this repo. Next, we have this pretty cool translation of UIKit components to SwiftUI. The next two links are not about SwiftUI, but relevant to the SwiftUI paradigm shift. The first video is by Facebook team on components, DOM-like hierarchical view structure with a similar design philosophy as SwiftUI. And next, a video by the Google Jetpacks Compose team on declarative UI patterns. Last, you can follow me on Twitter at Hello Sunshine, where I'll post a link to the slides later today. And that's it. I hope you enjoyed the talk.